We're looking at exploring exponential functions again today. We are this time going to be working with writing and modeling the equation. So we're going to be looking at how to write the equation that's created. And the basic format is you find the starting amount, and that's your A. Your growth or decay rate is your B. And how many times this is going to happen, aka your periods, is your X. And so to find your growth rate is typically positive, and so you take and add it as a decimal to 1, and that's it. So like if it was, let's say it was a growth rate of 80%, then it would be 1 plus 0.8. So my growth rate would be 1.8. But let's say you had a decay rate of 4. Decay rates are typically given with a negative sign. That's the reason there's a minus here. So if I change 4% to a decimal, it looks like this. So we're going to end up with 1 minus 4/100, which is 9.96. And that would be our decay rate. So decay rates are less than 1, growth rates are greater than 1. That's the way you can change it. It's possible to have like a growth rate of 9. But you cannot have a decay rate of less than 0. So let's start off with this first problem. We're going to go ahead and write out, I didn't give you a step 1 of this where you had to write out what the formula is, but we'll go ahead and do that. So let's figure out, what is our starting amount? Our starting amount is how much we invested with the $2,000. And then we need to figure out what our growth rate is. So we invested $2,000 with an annual rate of 5%. And the main question we're going to try to get to is how much will we have in 5 years? But to start off with, let's just write out our equation. So what growth rate would 5% result in? Stop this right now and you look at it. You'll see a question pop up in a second. And so you should have found your growth rate to be 1 5/100 to the X. So now if I want to figure out what's happening in 5 years, I'm just going to replace my X with 5. And just so you know, right now, some of the graphing softwares are out there for free. So check those out. And so we have 2,000 times 1.5 to the 5th. And when you type that in your calculator, what you come up with is 2,552.563, and it keeps on going more and more. Okay, with money, we round to the nearest hundredth. So this 3 is our last number. What does this 3 tell the 6 to do? It tells it to stay the same. So our final answer is we will have $2,552.56. Read the questions carefully on this and make sure you're rounding to the right place. Most questions are either going to ask you to round to the nearest dollar or they're going to ask you to round to the nearest cent. Now, let's say you want to figure out when will you have a certain amount. With the skills we have right now, and which we will learn more as time goes on, is we are going to use the graphing calculator's tables, and Desmos is one of the best places to go to find that. And so to go to Desmos, we'll type in the equation. You can either do y equals or like this. And here's the graph. It's really hard to read anything detail-wise off the graph. It's counting by hundreds, and so we know what's happening in the first 100 years, and it's looking like it's pretty early on in the first 100 years. But we can't tell more details than that. Remember, this little icon here will let you have an option of bringing a table. So you type in the table, and these numbers are changeable. So I went ahead and typed in 0, 1, 2, 3, and 4. So in the end of the first year, I'd have 2,100. At the end of my second year, I will have 2,205. And this is, if you didn't have another way of having a calculator, you could use this to help you find on the end of the 5th year. You could have done the 5 here and it would have helped you. And then you keep going. Well, I noticed that I'm pretty far off here, so I'm going to go ahead and try a 10. Well, the 10 was too far. So I start counting back. I went back to 8. Well, 8 was too small. And so that meant that I need to try a 9. We want it to be the first year it goes over 3,000. So in 9 years, I will have $3,000. Now, what happens if we're given a table instead of given the straight out, these are the numbers to plug in? We have to find it. So we're looking at the lynx species, and their population is exponentially decaying. And we're wanting to find out how many there were. The final question is going to be how many there are in 2014. But we're going to first come up with the equation. And so to step 1, we need to find our rate. And so to find the rate, we need consecutive periods, in which in this case we're looking at years. We're looking at annual rate of return. And so for most of our problems, it's always going to be years. But just realize in life, this is rate. It's going to be consecutive periods. It needs to be whatever you're counting by. If you're counting by days or if you're counting by months, whatever it may be, they need to be consecutive. And you will take y2 minus y1 divided by y1. So it's very similar to the slope formula. But instead of dividing by 2 numbers on the bottom, you'll have to take in, or you subtract them, you'll be dividing by just the first number. And years are typically considered our x. And we're going to actually count our x's to make this easier for us. We are going to count, this is year 0. So we're looking at how many years since 2003. And 2004 will be the first year since then. And that just makes our numbers easier to work with. So you usually put the starting year as 0. It makes it to where this table isn't looking at numbers in the past, because the past may not be following the same pattern. And so our y's are going to be the population. And so the starting amount is going to be the y1, and the y2 is the ending amount. So we have 120 minus 150 divided by 120. And so when I subtract those, I end up with a negative 30 over 120, which when I divide that all the way out, I get a negative 0.2. So remember, this is my rate. Oops, I didn't mean to put a y there. That was supposed to be r. Now, we have to get that to our b. And to find our b, because we are going to go to that equation, a times b to the x. And so to get b, you do 1 plus your rate. So 1 plus a negative 2/10, so 8/10. Now we got to find a. And so we're going to go to the equation y equals a to the bx, and we're going to plug in the information we know currently. Well, we know that in 2003, which was year 0, we had 150. So let's go ahead and just use that number, just because year 0 is the easiest one to start with. We don't know what a is. We know b is 8/10. And we know for that year, our x is 0, because we're counting how many years since 2003. And so in 2003, there hasn't been any years since. Anything to the 0 power is automatically equal to 1. So that's saying 150 times a times 1. Well, that means that a is 150. Now we're going to plug in and evaluate this function with finding out what's happening in 2014. So how many years have passed from 2003 to get to 2014? So 2014 minus 2003 means that there have 11 years that have passed. And so our x in this case is going to be 11. So let's go ahead and just write our original equation. So we found out that a is 150. B we found out to be 8/10, and just put it to the x. So let's plug in our scenario. 150 times 8/10 to the 11th power. And when you type that in your calculator to get the result, and again, you can use Desmos and use that table, or you can use one of the graphing calculators that are provided for you, that are starting to provide free resources. You come up with it being approximately 12.8, and it keeps going. Well, can we have a partial animal? The answer is no. So that means that we need to go ahead and round this to the whole, as that's approximately 13 are in existence at that time.